Okay, so this is chapter 6, chemistry, form 4, 6.2 pH value. Okay, the pH values of acids and alkalis. So at the end of this lesson, you are able to state the meaning of pH and its uses, calculate pH values of acid and alkalis, and number 3, investigate the relationship between pH value and also the concentrations of hydrogen ion and hydroxide ion. Okay, this is pH scale. pH scale ranges from 0 to 14. This pH scale is used to show the acidity and alkalinity of an aqueous solution. Okay, solution with pH 7 is neutral. Okay, and then solution with pH value less than 7 is acidic, and pH value more than 7 is alkaline. Okay, universal indicator pH meter or pH pepper is commonly used to determine the pH value. Okay, so what is actually pH? In chemistry, pH is a logarithmic measure of the concentrations of hydrogen ions in an aqueous solution. Okay, so this is the formula of pH. pH is equal to negative log the concentrations of hydrogen ion. Okay, here the logarithm of base 10, okay, is used, and this one is the concentrations of hydrogen ion, okay, in the unit mole per cubic decimeter. So using this formula, we can find the pH value of an acid. Okay, for example number 1, calculate the pH value of nitric acid HNO3 with 0.5 molar of hydrogen ion. So given the concentrations of hydrogen ion 0.5 molar, okay, so we want to find the pH value of nitric acid. Okay, so given the concentrations of H plus is 0.5 molar here, so we want to find the pH value using the formula negative log concentrations of H plus. So we just put the 0.5 here. Okay, so just press, okay, log 0.5 is negative 0.301. Here negative become positive, so the answer is 0.301. So the pH value of nitric acid with the concentrations of 0.5 molar is 0.3. Okay, 0.3. Example number 2, determine the molarity of HCl with the pH value of 2. So now we want to determine the molarity. The pH value is now given. So we just use the formula, the same formula, pH is equal to negative log the concentrations of H plus. Okay, so given the pH is 2, okay, we want to find the concentrations of H plus. So we just put the log H plus here in the left hand side, the 2 here become negative. So mathematic biasa. So the concentrations of H plus is 10 to the power of negative 2 ataupun shift log negative 2. So you will get 0.01 molar per cubic decimeter. Okay, so this is the molarity of the HCl with pH value 2.0. Okay, this one is for acid. How about hydroxide ion, OH minus? Okay, what is POH? Okay, POH, this is the concentrations of hydroxide ion. Okay, we can calculate the pOH using this formula. pOH is equal to negative log the concentrations of hydroxide ion. Okay, and then you should know that the pH value plus the pOH value is equal to 14. Okay, so to find the pH value, we just minus the 14, we just minus with the pOH value, we will get pH value. Okay, 14 minus pOH value, we get pH value. Alright, example number 3. Calculate the pOH value for sodium hydroxide solution NaOH with the concentration 0.1 molar hydroxide ion. Okay, so now we want to find the pOH value given the concentration. So just use the formula pOH is equal to negative log the concentrations of hydroxide ion. So here given 0.1, we just put 0.1 here, and then just press your calculator. So here negative 1, 1. So now the pOH value for the NaOH is 1. Okay. Example number 4. Calculate the pH value for potassium hydroxide that has 0.01 molar hydroxide ion. So here the concentrations of hydroxide ion is given 0.01, but we want to find the pH value. We don't want to find the pOH, but we want to find the pH. So firstly, you need to use the formula of pOH. pOH, okay, this one. Negative log the concentrations of hydroxide ion. So here given the concentrations of hydroxide ion is 0.01. We put here, okay, and then just press your calculator. Negative log 0.01. We will get the answer 2. Okay, 2 is the pOH, pOH value. So we know that the sum of pH and pOH value is 14. So here the pOH is 2. We can find the pH. Okay, so 14 we minus with the pOH. Okay, 14 minus 2, we will get 12. So the pH value is 12. Okay. Example number 5. Determine the molarity of lithium hydroxide solution with pH value 12. So here given the pH value 12. Okay, we want to find the molarity. So we know that pH plus pOH is 14. Okay, so to find the pOH value, we just minus 14 minus with the pH value 12. We will get the pOH value is equal to 2.0. Okay, so we want to find the concentrations of hydroxide, the concentration or the molarity of the lithium hydroxide solution. We use this formula pOH is equal to negative log the concentrations of OH minus. So pOH we get 2. Okay, so now this one we put here at the left hand side, and this one become negative 2.0. We want to find the concentrations of OH minus. Okay, we just shift the log. Okay, we will get 0.01 molar. So this is the molarity of the lithium hydroxide solution, 0.01 mol per cubic decimeter. Okay. Okay, the pH value can be calculated based on the concentrations of hydrogen ion in an acid or the concentrations of the hydroxide ion in the alkali. So pH scale allow us to compare the concentrations of hydrogen ion or the hydroxide ion in an aqueous solution. So there is a relationship between the H plus ion and the OH minus with the pH value. Okay, so this is the relationship. When the concentrations of acid increases, more acid molecule ionize to produce hydrogen ion. The higher the concentrations of hydrogen ion, the lower will be the pH value, so the acidity will increase. So the pH value will decrease. Okay, so remember, when the concentrations of hydrogen ion increase, the pH value will decrease, so this is more acidic. Okay, on the other hand, the higher the concentrations of hydroxide ion, the higher will be the pH value. So alkalinity will also increase, okay, when the pH value increase. So this is for OH, for alkali. Concentration of hydroxide ion increase, the pH value also increase, and the alkalinity also increase. Okay, so figure 6.11, this is the pH value of a few items in our daily life tested with the universal indicator. So this one is battery, lemon, gastric juice, okay, tomato, vinegar, coffee, milk, water, blood, baking soda, antacid. So antacid ini ubat sakit gastrik, ammonia solution, we have soap, bleach, and also sewage pipe cleaner. Okay, so next one is the strength of acids and alkali. Okay, strength of acid and alkali. So strong acid versus weak acid. So the strength of acid depends on the degree of dissociation or the degree of ionizations of the acid in water. Okay, strong acid means the acid ionize completely in water to produce high concentrations of hydrogen ion. Okay, for example, HCl, hydrochloric acid. This is a strong acid because all the molecule of HCl will dissolve in water and then will ionize completely and form H plus and chloride ion, hydrogen ion and chloride ion. Okay, so after the dissociation, no more molecules of hydrogen, chloride, HCl exist in the solution. So this is what we call ionized completely. Okay, ionized completely. So when the acid molecule able to ionize completely in water, so acid itu adalah strong acid. Okay, strong acid. How about weak acid? Memang weak acid adalah acid that ionize partially in water to produce low concentrations of hydrogen ion. For example, here this one is CH3COOH. This is tanoic acid. This is a weak acid because it only ionized partially in water. Okay, the degree of dissociation is 1.54% only. So meaning bila dia dissociate in water, dia akan produce hydrogen ion dan juga ethanoate ion, tetapi tidak semua molekul acid ini akan di-ion ataupun dissociate into H plus and this one ethanoate ion. Masih ada lagi molekul ethanoic acid yang tertinggal yang tidak ionized di dalam air. So itu kita panggil sebagai ionized partially. So acid begini adalah weak acid. So kalau kita lihat di sini, this one, dia punya arrow ada backward, ada forward, backward. Itu maksud dia ionized partially. Compared with this one, arrow dia cuma forward sahaja. So ini adalah ionized completely. So strong acid. So yang ini adalah weak acid. Okay, weak acid. So begitu juga dengan strong alkali and weak alkali. Strong alkali adalah alkali yang ionized completely in water. So dia akan produce high concentrations of hydroxide ion. For example, sodium hydroxide, dia akan ionize completely in water to produce sodium ion dengan hydroxide ion. So, after the dissociation, tidak ada lagi NaOH yang tertinggal ataupun molekul NaOH yang belum ionized di dalam air. So, ini kita panggil sebagai strong alkali. Tetapi kalau weak alkali, for example, ammonia solution NH3, okay, when we add with water, dia dissolve in water, dia cuma ionize partially sahaja. Okay, so dia akan form ammonium ion NH4+ dengan hydroxide ion. Okay, tetapi masih lagi ada ammonia yang tidak akan ionize completely in water. So ini adalah weak alkali. So remember, untuk mengukur the strength of acid and also alkali, okay, kita kena bergantung ataupun merujuk kepada dia punya degree of dissociation ataupun degree of ionization of the acid or the alkali in water. Okay, tidak semestinya acid yang pekat adalah strong acid dan tidak semestinya acid yang cair itu adalah weak acid. Faham tak maksudnya? Walaupun acid itu dilute, cair, tetapi kalau dia punya degree of dissociation tinggi ataupun ionized completely in water, still dia adalah strong acid. Okay, strong acid. Always remember the strength of acid and alkali mesti kamu rujuk kepada dia punya degree of ionization. Okay, degree of ionization. Okay, thank you.